All right, so this is going to come as no surprise to you, but there are currents in the oceans. Also, there are winds that blow over the top of the oceans, right? Well, both of those things have an impact on how oceans operate, and that's one of the things that you need to learn in this section of your notes. I wanted to start out with a term that I'm not sure you've ever heard of before. The term is called upwelling. Can you think for a second, what do you know about upwelling? Scale of 1 to 5. 5 means that you understand it completely and could do a presentation about it. 0 means that you had never heard of upwelling as far as oceans are concerned. All right, well, I'll give you a little inside information. Before I started teaching 8th grade, I had never heard of upwelling before. However, upwelling is more important than you would think. It's another one of those terms you've never heard of that has a huge impact on life. So essentially what happens with upwelling is this. There are winds that blow offshore. So the wind starts on the terrestrial portion of the earth and blows off of the shore out into the ocean. And you may not realize this, but when wind is blowing across the surface of the ocean, it's also pushing the water on the surface of the ocean as well. And if you notice here, that water that's near the surface of the ocean is generally warmer. So you've got offshore winds blowing warmer water out to sea. Does that make sense? Well, once that warmer water is blown out to sea, that leaves room for the deeper, colder water to fill its place. So warmer water is getting pushed out to sea. Colder, deeper water is filling its place, coming up behind it. That's why we call it upwelling. Do you understand that? Warm water is pushed out to sea by offshore winds, leaving a space behind it for colder, deeper water to upwell into its former location. Now, colder, deeper water rising all by itself wouldn't be that big a deal, right? Like, who really cares whether the colder water rises or not? Well, here's why that's important. In the oceans, there's lots of organic material sitting on the bottom of the ocean, right? Like nutrients that are decaying, like dead plant and animal matter that settles to the bottom of the ocean. Well, if it's just stuck there on the bottom of the ocean, those nutrients do nothing for us, right? Like, they don't help the oceans at all. Well, when the offshore winds carry the warm water away, and when the colder water upwells behind it, it also brings some of those nutrients from the bottom to the surface. We call that an area of upwelling. Now you've got all of this rich nutrient material that is pushing its way towards the surface in one particular location. Guess what that attracts? Lots and lots of other animals, right? All animals, wherever they happen to live, are trying to survive, thrive, and reproduce. So if an animal sees an area where there's lots of nutrient-rich material that just suddenly appears because of upwelling, it's going to attract those animals all into one place. And that's good, right? Because it feeds those animals, it provides them with a source of nutrients, and that's all great. However, take a look at the very last bullet on this slide. Almost half of all of the fish that are caught in the world and then sold are caught at areas where upwelling is occurring. So if you've ever eaten fish, or if we've ever relied on fish as a food source, then we count on areas of upwelling because fishermen know that in an area of upwelling you're going to have lots and lots of nutrients, which means lots and lots of small fish, which attracts lots and lots of big fish, which we then catch and sell as a food source. Isn't that amazing? So that one very act of offshore winds carrying warm water out to sea creates a situation where we can start to catch lots of fish as a food source. I would have never guessed that. So there's also lots of gases that are trapped in the oceans as well. Those gases aren't going to come as a surprise to you. If you look here in the very first bullet, you'll notice that those are nitrogen, oxygen, and carbon dioxide. We talk about those gases on the terrestrial portion of the earth all the time too, right? Well, what happens in the ocean is when you have wind and waves agitating the surface of the ocean, that's how you get gases that transfer back and forth between the atmosphere and the oceans. I always kind of wondered, well, how does oxygen get into the ocean? Well, one answer is that phytoplankton make it through photosynthesis. But in order to make oxygen through photosynthesis, you need to absorb carbon dioxide, right? Well, that raises a second question. How the heck do you get carbon dioxide in the oceans? Now, the answer is the agitation of the surface of the ocean through wind and through waves allows some of the carbon dioxide that's in our air to get churned into the water. Once it does, that carbon dioxide is absorbed by phytoplankton, who use it during photosynthesis, and then they release oxygen into the water. Now, why should we care about oxygen in water? Well, guys, it shouldn't be a surprise to you. Living things require oxygen in order to do cellular respiration. In order to be able to break down sugars and release energy, we need oxygen. That's why we breathe in oxygen. We learned that in 6th grade. That's cellular respiration, right? Well, when you're a water organism, when you're a fish living in the oceans, you still need oxygen in order to be able to break down glucoses to release energy. You have to do cellular respiration too. Just because you're an ocean organism doesn't mean that you don't survive in the same way. So the oxygen that is released by phytoplankton through photosynthesis then provides the oxygen necessary for ocean organisms to be able to complete cellular respiration and survive. Super cool, right? And one of the other things that I think is really important to understand about the gases that are in the oceans is that the ocean is absorbing carbon dioxide for us too. And don't forget, that very act of absorbing carbon dioxide is important to our survival. Scientists are pretty convinced that when carbon dioxide exists as a gas in our atmosphere, it holds on to heat. Well, so that means the more carbon dioxide that exists in our atmosphere as a gas, the warmer our planet will become. That's why you know that plants and trees are so darn important. They absorb carbon dioxide and they hold on to it for long periods of time. Well, guess what? The oceans are absorbing carbon dioxide too. Not only the plants that are in the oceans, but then through that agitation of wind and waves, carbon dioxide ends up becoming dissolved into our ocean's waters. And that's actually a really helpful and useful thing to you and I. Now, here's the hitch. The amount of carbon dioxide in the oceans has been steadily, slowly but surely rising over time. And so we have to ask ourselves, is there ever a point where the oceans won't be able to hold on to carbon dioxide for us anymore? Or is there ever a point where too much carbon dioxide in the oceans will cause a problem for the plants and the animals that live there? Those are things that we all need to think about. We should be happy that the oceans hold on to carbon dioxide for us, but we can't just assume that they can hold on to an unlimited supply of carbon dioxide for us.